So today we're going to look at area of triangles. Now you learned the basic area formula way back in the day. What is that formula? Did you find the area of a triangle? 1/2 base times height. Okay, so the area of a triangle is equal to 1/2 base times height. So that's fabulous if you have the base and the height, right? But what if we don't have the base and the height? We have some other options. So we're going to use this triangle over here. And it says we know that the sine of angle C, so here's angle C. If I'm going to just set up a ratio, I have to use the little right triangle that's right here. So the sine is opposite over hypotenuse. That will be h over a, the height over side length a. Then it says therefore h equals, so we're solving for h, so we'll multiply both sides by a. And I get a times the sine of angle C. Okay? So I can substitute. I've got h is equal to a times the sine of C, and I have an h right here. So instead of the height, I can just substitute it in a times the sine of C, but I'm going to switch the order of a and b. So the formula looks like this. Area of the triangle equals 1/2 a times b times the sine of angle C. Okay. And obviously the a, b's, and c's are relative to this particular triangle, but what ends up happening is that if you do label any triangle that you have a, b, and c, then when you label the corresponding sides and whatnot, whatever angle you're taking the sine of, the two sides that you use are the two sides that create the angle. And so it's always a side angle side type of setup. Okay. So if you've got side angle side, you can find the area of the triangle without knowing the height. You just have to know that angle there. Okay. Got any questions about that? Yes, ma'am. Because you can multiply in any order, and anytime you set up a formula, you usually put things like alphabetical and greatest to least, and it's the exact same thing. If we didn't, it's just if you see that anywhere, that's how you're going to see it. That makes sense? That's a good question. Okay, so we're going to find the area of this triangle here. So I have side angle side here, so I just get to substitute it in. Area of the triangle is equal to 1/2. And it doesn't matter which one A and B is anyway, just one of the two sides. So 1/2 times 16 times 11 times the sine of 105. Then you just put that in the calculator. You should get 85 point what? 001. Thank you. 001, and that is feet squared. Any questions? We good? All right. So let's look at the next one. The next one says the area of a triangle is 106 inches squared. Two of the side lengths are 25 and 21, and the included angle is acute. Find the measure of the included angle. All right, so I have a triangle. The area is 106 inches squared. I have two side lengths that are 25 and 21, and I want to know what the included angle is. Okay. So I have enough information to set something up. I can use my area formula. The area of the triangle, which they gave me, is 106. That's equal to 1/2 times one of the sides, which is 25, times the other side, which is 21, times the sine of the angle, which is theta. Everybody understand where everything came from? Just substituted it in. All right, so all of this is being multiplied by the sine of theta, so I can divide. So I get 106 over 1/2 times 25 times 21 equals the sine of theta. So what do I do to find theta? Inverse. Okay, so find the sine inverse of that. And we can say that the measure of the included angle is, you get 23 something. 23 what? 817. Very good. And that is degrees, because that's an angle. Any questions? Okay. So we have to have side angle side to do what we've been doing. We don't have side angle side here. But I have enough information that I can find something to get me side angle side. If I have this 76 and it's across from 7, 59 can allow me to find this angle. Would you agree with that? How do I find that? Using what? Law of sines, yes. So I'm going to have the sine of 59 over x equals the sine of 76 over 7. So x is equal to 7 times the sine of 59 over the sine of 76. Okay, but I'm not going to put that in the calculator yet, because if I do, I get a decimal, and some of us don't know how to handle those correctly. So we're just going to pause right there. I still, even knowing that side length, don't have side angle side though, right? I need, if I have this side that I just found and this side, I need this angle. I can find that. What's that angle? Subtract, yeah. And what did you get? 45. Okay. So 45 degrees. So now to find the area of the triangle, that is 1/2 times the 7 at times x times the sine of 45. Okay, well, this is x, so I'm going to take this, and that's what I type in right there instead of x, and let the calculator do it all at once, so I'm not using rounded numbers. Area of the triangle is 15 point what? 304. Very good. 304. We can't forget our units. Millimeters squared. Okay. What questions do you have? You use sine of 57 instead of 59. Okay. Anything else? No room for creativity. You don't get to change the numbers. All right. Oh, wait, I want to just point out one more thing on this. So here, on this one where we found the angle, it says right here the angle is acute. Well, that's what we got, and we didn't even go back and revisit that. But the next one we have, it's going to say that the angle is obtuse, so we got to make sure that we pay attention to that at the end of that question. Okay? So the area of the triangle is 25 meters squared. So let's draw a triangle. 25 meters squared. Two of the side lengths are 11 and 5, and I want the included angle. It says it's obtuse. Clearly my picture isn't to scale. It really doesn't matter. It just gives me something to at least put it in there. But I got to find the measure of the angle. So we're going to set it up the same way. I have the area of the triangle. It's 25. It's equal to 1/2 times 11 times 5 times the sine of theta. Okay. So that means I get 25 divided by 1/2 times 11 times 5. That's equal to the sine of theta, but make sure you actually find theta. You get that theta is 65 something. Okay. Is that what your calculator gave you? Okay, the problem is it says over here the included angle is obtuse. That is clearly not obtuse. You are taking the sine inverse of a value to get you that angle. You're taking the sine inverse of a positive value. Your calculator every single time will give you a first quadrant angle. That's all you're going to get out of the calculator is an acute angle no matter what. But we know that sine is positive in the first and second quadrants. So if we know that it's so we have basically two answers that could happen here. But I know it's supposed to be in the second quadrant. It gave me this one. What do I do with this information to get this one? Subtract it from 180. So in your calculator, you just do 180 minus answer, and you get that the measure of the included angle is 114.620. If it says it's obtuse, yes. Any questions? Anything else? All right. So number 5, we're going to find the area here too. Clearly don't have side angle side. Can I find an angle? I can. It does not matter which one I find. We're going to find this one just because it's the easiest place to write theta because the other ones are big or smaller angles. How do I find theta? Using what? Law of cosines. Very good. So what goes on the outside? Yes, 16 squared equals 6 squared plus 14 squared minus 2 times 6 times 14 times the cosine of theta. So then that means I get 16 squared minus 6 squared minus 14 squared divided by negative 2 times 6 times 14. That gives you the cosine of theta. So I want you to find theta. We're going to work this one a little differently here. You should get that theta is 98.213 something, something, something. So this time we're going to store it in the calculator. So remember, once you have that number looking at you, you do shift, recall, right parenthesis. Okay, so there's a couple of different ways to get the value back. If you just do recall right parenthesis, it gives you the answer, or it gives you that number back. But if we want it to kind of look like what we write, we're going to do that a little bit differently. So what I want here, so you stored this in x, right? So that means that when I go to find the area of the triangle, first of all, which two sides am I using? 6 and 14, good, because it has to be the two that make up the angle. I'm going to get 1/2 times 6 times 14 times, oh, my 14 looks weird. Okay, 6 times 14 times the sine, and I'm going to put the sine of x because we called it x. So if you want that exact thing to happen in your calculator, you type in 1/2 times 6 times 14 times the sine, and this time do alpha x, and things will kind of, and then you can see that it's actually what you want, and hit equals. You should get 41.569 yards squared. Any questions about that process? Are we good? Any questions? Awesome. All right, so there's actually a different way to do this one. Okay, the formula that I gave you, it works for all those, and if we have enough information, we can find it. We can totally use that formula, but there's going to be a much more straightforward way if you know another formula, and that's always a catch, right? So let's talk about Huron's formula. It doesn't even require trig. So it says when the measures of all three sides of a triangle are given, side, 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 like this right here, you can use Huron's formula for the area. So Huron's formula requires an S, which is equal to 1/2 times A plus B plus C. If I just did A plus B plus C, what information does that give me? The perimeter. So I just want half of it. So half of the perimeter is called the semi-perimeter. Okay, so that's what S is going to be in here. You have to find the semi-perimeter. And y'all know that I find it very important that you understand where things come from, and I want to show you how we derive things. I'm not showing you this one. If you want to know where this one comes from and why, it's on YouTube. There's some very good explanations, but they're kind of long, and it's crazy algebra. But if that kind of thing interests you, you can see that it's not that somebody just, Huron didn't just make something up. Like, it actually works. Looks like this. Area of the triangle equals, so it's a big old long square root, and it's S times S minus A times S minus B times S minus C. So even though it looks yucky, it's a relatively simple one to remember. Not really a relatively simple one to derive. I think you could follow it, but we wouldn't have to do it. Okay, so let's see how this works here. We've got the side here, and I need S in order to find this. So S is equal to 1/2 times 18 plus 19 plus 21, and that gives me 29. Okay, so 29 is your semi-perimeter. So the area of the triangle then is big old square root. I get 29 times 29 minus 18 times 29 minus 19 times 29 minus 21, and then I would just let the calculator do it all. Don't even try and subtract in your head. Not worth a brain fart. You get 159 point what? 750, and this is miles squared because it's area. Any questions at all? All right, then y'all do number 7 on your own. So that's what I got. Do you agree with me? Yes. What if I were to tell you my answer isn't right? What? Nearest tenth. It says, find the area of the glass to the nearest tenth of a square inch. So my answer is area of the triangle equals 173.5 inches squared. It is 3 decimal places unless you are told otherwise. You have to read it and know when to round how. What questions you got? Anything? Awesome. Then you got lots of time to work. So get to work and use your time wisely.